So we're spending a couple of days reviewing all the different kinds of factoring that you would have learned in grade 10. If for some reason you haven't seen this before, then I don't know what to tell you. Although I will be sort of teaching this from scratch, it's going to go a lot faster than we would do it the first time around in grade 10. So it's really important that you understand these skills and that you get this. If you have to watch the video over and over, that's fine, or watch another video, or contact me some way. You need to know this material. Everything else in the whole unit will depend on it. Okay, so this is very important. This is a fundamental mathematical skill. For whenever we're talking about factoring, it's about patterns and making connections with patterns. And so we need to know how we got there in the first place. This is what I call it, at least. How did we get there in the first place, okay? So if I have, you'll notice all these binomials are very similar. They all have x and then plus or minus a number, and there's 2 of them, okay? All 4 of these look the same. So if I'm expanding, I'm doing x times x, then x times 3, then 4 times x, then 4 times 3. So this gives me x times x is x squared, x times 3 is 3x, 4 times x is 4x, and 4 times 3 is 12. Okay? And then, again, because these are set up to be so similar, all 4 of these questions are set up in the same way with the x's and the numbers, we always have this pattern where the 2 middle terms can be added together because they're like terms, and we end up with this trinomial. And so what we've noticed is the 3x and the 4x add to 7x. Okay, let's do the next one. So we do the same thing, x times x times 7, 3 times x, 3 times 7, and we notice that there's 2 terms in the middle that add together. 7 plus 3 is 10, okay, to give us that middle term, and we end up with a trinomial again. 2 more. X times x is x squared, x times 3 is 3x, negative 2 times x is negative 2x, negative 2 times 3 is negative 6. Once again, we see these 2 middle terms. 3 minus 2 is 1, so just x, 1x. And finally, x times x is x squared, x times negative 5 is negative 5x, negative 1 times x is negative x, negative 1 times negative 5 is plus 5, and I end up with x squared minus 6x plus 5. So this is not factoring, this is expanding, okay? And all those middle terms we see added up to a single term. And all 4 of these cases, the solution is a trinomial. The first term was always x squared, and the last term was always a constant. By that, I mean it has no variable part. Okay, so there's a lot of patterns here. The other pattern we see as we go through it, and maybe you've already noticed, is this is 3 plus 4. This is 3 times 4. This was 7 plus 3. This was 7 times 3. This one is 3 minus 2 to get the 1, 3 times negative 2 to get the 6, and this was negative 5 minus 1, and negative 5 times negative 1. So in each case, in each of these 4 cases, the middle term is you get by adding these 2 numbers, and the last term, the constant, you get by multiplying those 2 numbers. Okay?
Ms. Snyder, call.
So that's the pattern that we need to notice, and we're going to take advantage of that in order to factor. When I expand, which is going this direction, I start with the brackets and I multiply and then simplify. When I do that process, it's a series of steps, right? I multiply this times this, then this times this, then that times that, and that times that. And I can collect like terms to get my final answer. But when we're factoring, that doesn't work. Factoring almost always takes advantage of a pattern that we notice, and this is the pattern. The pattern is that I've got an x squared and a constant, and the middle term is 2 numbers that I've added together, and the last term is those same 2 numbers multiplied together. That's the pattern required for this kind of factoring. The last thing that you want to notice is the signs. In this case, everything's positive. So the 7x is positive and the 12 is positive. Whoops. And same thing here, the 10x is positive and the 21 is positive. And notice that both brackets were all positive. Not the same for these ones. When I multiplied negative 2 times positive 3, I got a negative result. But because the 3 was bigger, the middle term was positive. If the negative number was bigger, the middle term would have been negative. I would have had a negative here when I multiplied, and I would have had a negative here because the negative number was bigger when I added. But in this case, that middle term was positive. Now take a look at this last one. The last term is positive because I multiplied two negatives together. And then when I added two negatives together, I got a negative. So there's some different sort of connections that we need to make here. In this case, the last term was positive, and in this case, the last term was positive, and that's because the signs are the same in both cases. Okay, and again, we need to make that connection because we're going to take advantage of that in order to do the factoring. That's how we get there. Factoring is going the opposite direction. Factoring is when you start with this and you're trying to turn it into that. Okay. Before we get started, these are going to be called simple trinomials, which is the focus of today. But before we do that, we're going to sort of step to the side and do something a bit different. Just very quickly talk about common factoring because that's something that's going to come up here and there as well. So quickly, we'll do some common factoring. Common factoring is when I look at both terms or all the terms and see what's common in the numbers and what's common in the variables. And by common, I mean something you can divide out of both. So 14 and 21, I can divide a 7 out of both of those. And because they both have a y, I can also factor a y out of both. And then I have to figure out what's left in the brackets. And what's left is what makes it work. So when I do 7y times 2y, I get 14y squared. And when I do 7y times negative 3, I get negative 21y, right? So you're dividing the 7y out. But you can also think about it as what would you multiply by to get back to that. Okay, and this is not a question that we'll see very often in this course, but it's a good question to just understand the rules of common factoring, so that's why it's here. Most of the common factoring we're going to have to do will actually be fairly simple. Okay, I'm going to start by looking at the numbers, so 20, 15, and 25, and I can divide a 5 out of all of those. Now I'm looking at the x's, okay, and this can be a little bit tricky, but I'm looking for what the smallest exponent that's in all of them. So they each have at least x squared, because x cubed is bigger than x squared. So I can factor out x squared. And then looking at the y's, they each have at least y squared. So I can pull out a y squared. Now for figuring out what's left. And I can either think of this as dividing or think of what would I put here to multiply and get back that. So this would have to be a 4, because 5 times 4 is 20. Or I could say 20 divided by 5 is 4. Both of those work. X squared divided by x squared is 1, so that's gone. Y cubed divided by y squared, well, when you're dividing powers with the same base, you subtract the exponents, so it's y to the 1. 15 divided by 5 is 3. X cubed divided by x squared will leave just a single x left. And y squared divided by y squared is 1, so that's gone. Negative 25 divided by 5 is negative 5. And take a look. X squared, y squared, x squared, y squared. So that whole part is gone. And we're left with just negative 5. Okay, so that's a quick look at common factoring. There's not going to be a lot of that in the practice today. It'll come up in a future lesson. We'll do it, but it won't even be this hard. It'll be fairly straightforward. Okay, that was our stepping off to the side in order to do a little bit of common factoring. Now we're going to get back to simple trinomial factoring. And here we go. Again, this is something that you're supposed to have seen, so I know I'm going through it a little bit more quickly. You can pause and rewind the video. You can go back and look at the intro where we talked about where it came from. That's the connection you have to make. But ultimately, factoring is not a matter of steps. It's a matter of understanding the patterns and knowing what the answer is going to look like. If I go back up here quickly, remember all of them were two brackets, and each of them started with x. So when I see these simple trinomials, I know that that's always the case. Now, my only job is to figure out what numbers go into these blank spaces. It's going to be plus something or minus something for both of them. And remember, from the pattern, it's two numbers that multiply to 4 and add to 5. And you have to know your times tables, or you have to be willing to do guess and check on your calculator. There's not really a system of how you do this. You just have to kind of come up with those numbers. And so two numbers that multiply to 4 and add to 5 are 1 and 4. 1 times 4 is 4. 1 plus 4 is 5. And the whole point is, if I were to expand, I get x times x, which is x squared, x times 4, which is 4x, 1 times x, which is x, and 1 times 4, which is 4, which would be x squared plus 5x plus 4, which is what I got here. Now I'm going to erase this. That was my check. Actually, maybe I'll leave it for this one. That was my check. But you don't want to do this after you finish factoring. You can check on a separate piece of paper, but that's your answer, and you want to leave that. In grade 10, we do get students who factor it, and they're like, oh, hey, maybe I should expand it, and they leave that as their answer, but that's not what we want. This is the factored version. That's your final answer. That's what should be on the page. Okay, again, whoops, back to blue. I know that it's going to look like this because I recognize it as a simple trinomial. I know they're each going to have an x in the front, and there's going to be two brackets, and I'm looking for two numbers that multiply to 12 and add to 8. And so those numbers are going to be 6 and 2. 6 plus 2 is 8. 6 times 2 is 12. And it's as easy as that. And if you're good at your times tables, and the way I think of it is I always think of possible pairs of numbers that multiply to 12, because there's a lot of numbers that add to 8. There's an infinite list of numbers that add to 8. But there's only a much smaller list of numbers that multiply to 12. 1 and 12, 2 and 6, 3 and 4, and that's it. So if I try all of those, 3 and 4 is 7, 1 and 12 is 13, I'm adding them together, right? 2 and 6, oh, that's 8. I got the right answer. Now it changes when you have a negative. So we can go back and look at the patterns above, but watch this for a moment. If these two numbers, whatever goes here and whatever goes here, when I'm going to multiply them together to get this number here. If it's a negative, I know one of them has to be positive and one of them has to be negative. I know they have different signs, which means I'm not actually going to put those in yet. I'm going to do that after. But I'm thinking to myself, one is adding and the other is, one is going to be positive and the other is going to be negative, which means when I add them together, they're actually going against each other, and the difference between them is 7. So in this case, it was 6 plus 2 is 8. But for this one, I would be doing 6 minus 2 and trying to get 7. So I'm looking for two numbers that multiply to 30 and subtract to 7. And what numbers multiply to 30? 5 and 6, but 6 minus 5 is 1, so that's not going to work. And the numbers, of course, are 10 and 3. 10 times 3 is 30, and 10 minus 3 is 7. And then the last thing I'm going to do is I'm going to think about which one is positive and which one is negative. That's the last thing I'm going to do. And because this is a positive 7, I want the bigger one to be positive, so it's 10 minus 3 gives me the 7. And that, again, that's logic that you have to be able to make sense of and work out on your own. Every question, you're going to look at the signs and use them to think about what the signs of these numbers will be in your answer, and take that into account when you're doing it. And so this one is a little bit different because it's got two negatives. They're both negative, okay? But again, because the 16 is negative, that's what we're multiplying to. I know they'll have different signs. So two numbers that multiply to 16, 4 and 4, that's not going to work. 1 and 16, that's not going to work. Looks like they're going to be 8 and 2. 8 times 2 is 16. 8 minus 2 is 6. But in this case, I want it to be negative 8 because it's actually 2 minus 8 or negative 8 plus 2 that gives me the negative 6. Okay, if you need to pause the video at any time, I know I'm going quickly, and to think about this or rewatch a little bit of it to make sure you're catching everything. Some people the sign stuff makes sense and they just get it. And some people really need to spend some time thinking about it for it to click. So you have to think about yourself and your understanding, and are you understanding how I'm getting the signs, how I'm getting which one's negative and which one's positive, and how I know what the signs are going to be, if they're going to be the same or different. This is the last type of question in terms of what the signs are like. Okay, so I've got X, and I'm looking at this thing. They're going to multiply to 15, and 15 is positive. So what does that mean? It means they have to have the same sign, because two positives multiply to a positive, or two negatives multiply to a positive. If they have a different sign, they're going to multiply to a negative. But look at the middle term is negative, so they both have to be negative. And when I'm adding two negatives, I actually add them together, right? So -2 plus -3 is -5. 2 and 3 is 5, and it stays negative. So these are all little, understanding of how integers work, adding and subtracting integers with negative numbers, multiplying integers with negative numbers. Like, all of this is background knowledge that you have to have and be comfortable with in order to factor. And some people might already be asking, if they're confused, isn't there an easier way to do this? Can't you show me an easier way? There really isn't. You have to have some number sense to be able to factor. So I believe the numbers in this case are going to be 3 and 5. -3 times -5 is positive 15. -3 plus -5, or -3 minus 5, is -8. The nice thing about factoring is you can always check your answer, and again, don't do it in the space below. Do it off to the side or on scrap paper or in your head if you can, but you can always re-expand and make sure that you get back what you started with, and you'll know that you had the right answer. So even if your number skills aren't great, you can do a little bit of, it's a lot slower, but you can do a little bit of guess and checking to get the right kind, to make sure you've got the right answer. Okay, I believe this is the last one. This one's different because it's got a 2 out front. Now, this is what we're going to do in the next lesson. We're going to talk about how to factor when there's a number out front, because all the ones we've done so far don't have a number out front. And we'll talk a lot more about this. When it has no number out front, like in example E, it's just x squared, 1x squared. That's what makes it a simple trinomial. So this one looks like it's not a simple trinomial because of the 2. But it turns out that 2 is a common factor, and I can common factor it out. Okay, like that. I divided it out of all 3 of those terms. There was no x to divide out. I just divided out the 2. This is the kind of common factoring we're going to see in this course. So like I said, it's a lot more simple. And now I have left a simple trinomial in the brackets, and I can go ahead and factor that. Okay, and so I'm going to do that first, and then I'm going to talk about this a little bit further. 2 numbers that multiply to 36 and have a difference of 5, because the 36 is negative, so they have to have opposite signs. And these are going to be 9 and 4. 9 times 4 is 36. 9 minus 4 is 5. But I want the 9 to be negative, so I get a -5 in the middle term. So that's the last one. It had a common factor. That's what made it different. We are going to learn how to factor when we have a number out in front of the x squared term. That's the next lesson. Last thing I want to say is I don't believe there are any questions like this in the practice, but for lesson 3 there will be. So in a couple more lessons, that's when we're going to mix them up a little bit more, and you will have to do some common factoring as well as other kinds of factoring. So we'll mix it up and learn how to tell what you're looking for. So it is coming, but the practice today, I believe, doesn't have any of those. It's all just simple trinomials. You always want to keep in mind, oh, there's one more question I forgot. You always want to keep in mind that it's 2 numbers that add to this and multiply to this. That's the key to simple trinomial factoring. I'm glad I noticed this. This is the last one. This is hopefully an easy one. Once you get this one, you like it. If you haven't seen this before, I'm not really explaining where it came from, so you'll have to ask and I can give a better explanation or find a video of your own. But these are called the difference of squares because both of them are a perfect square. And by perfect square, I mean when you take the square root, you get a whole number. So if I do the square root of 25, I get 5. Whereas if I do the square root of 26, I get a decimal, not a whole number. Okay, that's what we mean by perfect square. And when you have and there's a minus sign between them, so when you have a difference of squares, it looks like this again, like a simple trinomial. But in the brackets is a +5 and a -5, and that's because it's just, that's because 5 is the square root of 25. So one more, plus 9x minus 9, because 9 is the square root of 81, and again, this is a difference of squares. And if you want to know why, you can expand x times negative 5, 5 times x, 5 times negative 5, and see why this works and understand the pattern. In a difference of squares, these two numbers will always be the same. These two signs will always be different. They'll always be opposite. Okay, and that's the pattern. So that's all factoring we should have already seen. That's why I went through it quickly. Hopefully that made sense. If not, make sure you ask questions or watch the video again or try a few on your own and try to just follow the steps that I gave you.